So lesson 5.3, there are a lot of examples. We're going to do like maybe 3. Okay, I'm just going to hit and pick some examples that we need to talk about to help us with solving. For the most part, there's one brand new method I'm going to show you, which has to do with cubes. But other than that, this stuff is all old news. You should know how to factor product and sum. You should know how to do product of AC. Factoring by grouping. These are things that you should know. Whether you remember them, it's a whole other story. Okay? So we're just trying to adding on a little bit and reviewing. So methods of solving polynomials. This is all going to be related to factoring. When we factor, well, almost all related to factoring. We can factor out GCF. That sometimes helps. Quadratic factoring. When I'm talking about quadratic factoring, I'm talking about product and sum or product of AC. Those are methods that should sound familiar. Quadratic formula. If factoring fails, you might need quadratic formula. And I'm not going through a quadratic formula. I don't think there was any in homework. I more tried to focus on factoring. But just beware. Differences of squares. This is one we tend to have to review. Quick example. When I talk about differences of squares, do you remember how to factor x squared minus 25? It's differences of squares because x squared is a perfect square, 25 is a perfect square, and it's a difference because it's subtraction. What does this factor into?
X plus 5, x minus 5.
Okay. So it has to be written as 2 separate parentheses, but the square root of x squared is x. You put that in the front of each parenthesis. The square root of 25 is 5. You put that at the end of each parenthesis, and if it multiplies to be negative, you need a plus and a minus. You guys had to do that in the last test, right? Yeah. Okay, so that's old news. Just reviewing it. Factoring by grouping. You guys remember factoring by grouping? You use it within product of AC is what I'll tell you. Okay, so when we talk about factoring by grouping, and I'm not going to, okay, so forget the equal 0 for right now. I'm not going to actually solve this because you guys would know how to solve it once we get factored. But with product of AC, we talk about factoring by grouping because when there are 4 terms, what do you do when there are 4 terms? You take those 4 terms and split it in half. Does that sound familiar? This is factoring by grouping. I don't refer to it by that name when we do product of AC, but this is factoring by grouping. So now you're looking at the first 2. So forget the back half. What do x cubed and 2x squared have in common?
X to the second.
X to the second. So we factor out x to the second. X to the third divided by x to the second is x plus 2x squared divided by x to the second is 2. Back half. So now, forget the front half. What do negative 3x and negative 6 have in common? Both 3, specifically negative. Negative 3x divided by negative 3? X. Negative 6 divided by negative 3? Plus 2. I'm not doing the equal 0. Are we on the right track with our factoring?
Yeah.
How do we know we've made good choices?
They're the same.
X plus 2's match, right? So how do you write the factored form of this?
X squared
X.
3 and x plus 2.
Okay. So my x plus 2's are in common. That's one of my parentheses. It doesn't matter which. And then when I pull out the x plus 2's, I have my GCS of the x squared minus 3. You know how to do that, right?
Yes.
It's called factoring by grouping, but here's the deal. When you see 4 terms tonight in homework, this is the type of factoring you're going to want to work with. Now, question. If this was an equal 0, and we had to solve this equation,
You set both equations.
set both factors equal to 0, does that sound familiar? And you could solve that, right? X plus 2 equals 0. You get x equals negative 2. X squared minus 3. Well, you'd have to add the 3 and then take the square root, right? So know how to do the factoring by grouping. Now, this is the newbie. Factoring sums and differences of cubes. So not perfect squares, but perfect cubes. And that's what we're going to spend a bit of time on. When we talk about this, we're talking about pieces that are in the form, well, really in the form of a cubed minus b cubed. Like this is the one we're going to practice with here in a moment. So in the form a cubed minus b cubed, or this one would be in the form a cubed plus b cubed, right? So what I'm actually going to do over here, we're not going to do this first example. I'm going to write the formulas out that it would be helpful for you to know. So if something is in the form a cubed plus b cubed, it factors into a plus b times a squared minus ab plus b squared. So this factors into a binomial times a trinomial. If instead it's of the form a cubed minus b cubed, it's just two signs change. Instead of a plus b, it's a minus b. And then over here, it's a squared instead of minus ab. Whoops. It's plus ab. And then still plus b squared. Okay. I would get those written down because those are really, really helpful to know. Okay, really be familiar with them. What I'm going to do right now is I'm going to walk you through how to use that. Because seeing it and understanding how to use it is not the same thing, is it? Right now it looks like a bunch of gibberish to you, I'm guessing?
Yeah.
Okay, so my goal is to make it a little less gibberish. Maybe something you can use, maybe. Okay, so I want to look at this 27x cubed minus 64. And again, I'm not going to worry about the equal 0 part right now. I trust you guys know how to take a parenthesis and set it equal to 0. My concern is we need to know how to factor this, right? So, with this in mind, this fits into the form 27x cubed is a perfect cube minus 64 is a perfect cube. And so this fits into the form of a cubed minus b cubed. The first thing I want you to do is find the cube root of each part. Okay, so what is the cube root of 27x cubed? So what is the cube root of 27? What times itself a third time gives you 27? 3. 3 times 3 times 3. And what's the cube root of x cubed?
1.
X.
X.
So right there, cube root of 27x cubed is 3x. I also want to talk about the cube root of 64. You can start guessing numbers and seeing what times itself again. Your calculator will do a cube root, and I can help you figure that out later. But the cube root of 64 is 4. Because 4 times 4 is 16, times another 4 is 64. So what we've just done, 27x cubed was what in the position of a cubed, yes? So when I take the cube root of 27x cubed, this 3x is my a value. 64 was in the position of b cubed. So when I take the cube root of b cubed, this 4 is in the position of b. So what we have just found are values we can use to put in our formula for a and b. Now, which formula do I need to use over there?
The bottom one.
This is a cubed minus b cubed. So we're going to use that formula and fill it in. So first thing I'm going to do is I'm going to fill in this binomial here. Binomial means, remember, it's two terms. So it's parenthesis. It's a minus b. So what was my first cube root? 3x. Keep the same sign that was in the given problem, which is minus. What's the cube root of the last term? 4. Are we okay with that? Then we have a trinomial. Trinomial, first of all, it's a squared. So it's that cube root, then we have to square it. What do you get when you take 3x and you square it? Make sure you square the 3. And so 3 squared and the x squared is going to be 9x squared. Your sign after a squared is always the opposite of the original problem. My original problem was a minus. That means this is a plus. AB. That means I'm taking one cube root times the other cube root. And 3x times 4 is 12x. And then plus b squared. Hello? I will do that. Bye. My Kaylee daughter, Mrs. Fields, would like to see you, and you're not in trouble. Mrs. Fields, Mrs. Henry, whoever she is. Okay, did you guys fill in b squared without me? It was the cube root of 64, which was 4, and we're going to square it, so 16. Okay, this is what that would look like in factored form. Like earlier, you would then have to set each part equal to 0. And because of this second one, that's where quadratic formula will come into play today. Okay? And again, I'm not sure where I'm at on time, but my goal is to get to an example like that. Where am I at on time?
15 minutes.
I can do this. I can do this. Maybe I can't.
Our delays are great until they're not great anymore.
I know. This is, as a teacher, when I get that 2-hour delay call, or in this, I usually see it on Twitter first. When I get that, I'm like, okay, how does this affect my classes today? Can I make it work? Today was not a good day for a 2-hour delay.
I'm
But
kind of excited because I slept in, and then I woke up like 15 minutes before the bus was get there with like 3 texts from my mom asking if I'd be awake, and I wasn't awake.
example A. Gotta keep moving here. Notice it does say, what are the real or imaginary solutions? So I's can show up today.
No.
Yep. Okay, gotta get moving. What do you think the first step needs to be? We have these terms.
Divided.
0. I heard several people say 0. How do I make this equation equal to 0?
Madison Edwards, please come to the high school office. Madison Edwards.
Subtract 3x. 2x to the third. Minus 5x squared. Minus 3x equals 0. Okay, some of you guys went right to that. You knew exactly what I was going to say. We need to make the equation equal to 0. Think factoring. Is there a GCF?
X.
They all have an x. Do they have a number in common?
No.
Nope, just x. So I'm going to factor that x out front. When I factor that x out front, it becomes 2x squared minus 5x minus 3. Okay. No matter what we do from here, this x out front will drop down. That is going to represent a solution. We will set that equal to 0. How do we factor 2x squared minus 5x minus 3?
Product of AC.
Product of AC. I picked this one. Do we need to review product of AC? Based on the test, I'd say some of you do.
Oh, shit.
Okay. Product of AC. What is A and C?
2 and
2 and -3, which is -7.
And obviously I'm writing under B because we're not doing B. Okay? So product of -6, a sum of our B term, which is -5. What multiplies to be -6 and adds to be -5?
3 and 2. I was gonna do 6 and 1.
6 and 1.
-6.
Because of the signs,
Oh.
we're going to have to use 6 and 1.
Dang, Alexis.
Otherwise, I was with
You
you
said
on
it
2 and
first.
3.
Oh.
Now, okay, ladies, -6, +1. Okay? Because we need it to multiply to be a negative, so I need a positive and a negative sign. So to get them to, they have to subtract to be 5. So 6 and 1. Now, what do I do?
Split them.
-6 and 1, we're going to split the middle terms. Now, be careful. Stay organized here. The 2x squared is just going to drop down. -5x. What do you guys, I'm just going to go with -6x plus 1x. And then I also need to
-3.
drop the -3 down.
So, do you drop the 0?
And it's still going to equal 0, yes. Okay. The x out front. Keep dropping it, yes? Inside your parentheses, I can't change the brackets because I know I'm going to need brackets in a moment. I have 4 terms. How do we factor 4 terms? Split it in half. And so GCF of 2x squared minus 6x. 2x. 2x squared divided by 2x is x minus 6x divided by 2x, 3. GCF of 1x minus 3. Just 1. Don't tell me nothing. I have to have something here. So 1 leaves me with n x minus 3. X out front.
Drop it.
Drop it down. And then we have 2 parentheses, yes? Ignore C. Sorry, I'm running into C, but I'm not doing C either, so we're good. At least I don't think I am now. Okay, one of my parentheses is
2x plus 1.
2x plus 1. The other parenthesis is x minus 3. My equation still equals 0. I should be done now. You don't need my help from here on out, right?
Are we doing the zeros?
We are solving this one.
Okay.
So how do I actually finish solving?
Set everything equal to 0.
Set each part equal to 0. And honestly, I'm just going to keep going down below here. I'm going to have x equals 0. I should have asked you guys. You didn't forget the x, did you?
No.
I'm going to have 2x plus 1 equals 0 and x minus 3 equals 0. How many answers am I going to have? 3. And considering my height power was x to the third, I would expect to have 3. So x equals 0 is x equals 0. 2x plus 1. Subtract 1. And divide by 2.
X equals -1.
So we've got negative 1/2 there. We already had 0. And if it was x minus 3, you had to add 3. So x equals 3. So you would need all 3 solutions on a problem like this, wouldn't you?
Yeah.
Okay. Although I didn't do anything you didn't know how to do there. I did GCF. I did product of AC. I solved by saying each factor equal to 0. Yes?
What's up with the brackets? Why do you have to switch brackets?
Okay. I should not have necessarily switched to brackets right here. we were still fine to use
I
parentheses.
understand them, I just didn't know.
Yeah, and they really have no different meaning. The only reason I really needed to switch to brackets here is just because parentheses within parentheses, so it makes a little bit more sense to say brackets here.
Okay.
I just got ahead of myself a step there. Does that? That's honestly what it
We
is.
had to like switch them like the first time, like the second.
And you can use parentheses and parentheses if you want.
It's
that
just
would
easier
work.
to show it with the brackets.
Okay, let's go down. I'm not gonna, I wanted to do E, but I'm gonna have to skip E. Let's go down to I and see what we can do with I. Okay. First of all, I see parentheses, so
Distribute.
I'm gonna go with distribute. So when I distribute, and I'm going quick, I hope you guys are keeping up, sorry. I am trying to go quick and not go quick at the same time, does that make sense? We distribute okay though, yes? Out for 2, I mean in reality you guys can all distribute great. Then, what would you expect I'm gonna say to do? Okay, so if we're going to make our equation equal to 0, I'm going to keep the x cubed over here, so I'm going to subtract 8x from the right and the left, and I'm going to subtract 8 from the right and the left. X cubed is still x cubed. 8x minus 8x? Gone. And then we still have a minus 8 equals 0. Now, so this becomes x cubed minus 8. Here's the deal. No, you cannot just add the 8 over and take the cube root. Darn it. That will get you one of your 3 answers. And you'd be missing the other 2. So, I taught you a factoring on the front side, didn't I? This fits into the form of a cubed minus b cubed, doesn't it? And I'm going to write out my formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So can we factor this? I'm hoping so. Find your cube roots. What's the cube root of x cubed? X. And that's going to go in the position of a. And then we also need the cube root of, just think 8. I don't worry, I worry about the signs with the formula, okay? What's the cube root of 8? 2. And that 2 is going to be in my B position. Does that make sense? Because it's a cubed minus b cubed. Ready to try and fill it in? Okay. A minus b. That's my cube root of each. So x minus 2. Then a squared, which is x squared, plus ab, so a times b, 2 times x, 2x, plus b squared. What's b? 2 squared, so 4. And officially, my equation still equals 0. I will tell you, x squared plus 2x plus 4, as much as we want it to, it does not factor anymore.
Darn it.
Okay? So we need to set each part equal to 0. We have x minus 2 equals 0. And we have x squared plus 2x plus 4 equals 0. Let's get the easy one out of the way. What do we know about x minus 2 equals 0? Add 2, x equals 2. Don't forget that answer. That's the easy answer. Okay, how do I solve that other one?
Product of quadratic.
Quadratic formula. Okay, do I have time? Okay, quadratic formula. I'm going to go quick. Negative b, so negative 2, plus or minus the square root, b squared, so 2 squared, minus 4, times a is 1, times c is 4, all over 2a, 2 times 1.
Pardon the interruption. At the beginning of 6th hour, I need all middle school cross-country members to report to the gym. At the beginning of 6th hour.
Negative 2 plus or minus. Under that radical, I ended up with 4 minus 16, which is negative 12, all over 2. Negative square root, guys. What's that going to mean about my answers?
You have an I.
Yeah, here, side note real quick. Square root of negative 12. There's a negative 1. And what else does 12 have in it? I don't like 2 and 6.
4 and 3.
4 and 3 because 4 is a perfect square. So square root of negative 1 is I. Square root of 4 is 2. Square root of 3. So we end up down here, if you give me just a moment, negative 2 plus or minus 2i square root of 3 all over 2. They all have a 2 and negative 2 over 2 is negative 1. Plus or minus 2 over 2 cancels I square root of 3. You have 3 answers to this problem. The 2 and these 2 right here. Okay, try the homework. I know I'm a little short. I have one more example I wanted to do. Try the homework. We'll reconvene Monday and see where we're at. Okay? Lesson 5-3 in Math Excel, please.
What? What did I just walk into?
You're not looking at anything.
I'm sitting here.